This is a part 3 of monopole antenna design. Now we will discuss and see the effect of varying radius of monopole antenna on return loss plot, how the bandwidth can increase, how the directivity is going to change, how the VSWR value is going to change from inductive to capacitive or capacitive to inductive region, and we will see other changes occur by increasing the radius of monopole or by decreasing the radius of monopole antenna. First of all, the design I have created in part 1. Add parametric sweep in the monopole radius. The parameter uses MR. Add the radius for 0.9 GHz operating frequency is 2.23. Now I am going to add it from 2.1 to 4 with a step size of 0.2 and update it and press OK. These are the different values of radius of this monopole at which it will generate the results for 2.1, for 2.3, 2.5, 2.9, similar up to so on. Press OK and analyze this. I have already analyzed this. Now I am going to check the result. This is the return loss plot, which is S11 plot of this monopole antenna. Now you will observe from the different by increasing the radius of this monopole antenna. Now here you can see that this is the lowest radius, which is 2.1 mm, and this is the highest. From here you can see that this is the resonance frequency. The resonance frequency slightly decreases with increase of radius of monopole, but the bandwidth is slightly increases with the increase of radius of this monopole antenna. Now I am going to check this. This is 2.1. This is 2.1 GHz. This is 2.1 mm radius of this monopole. Here is 0.96 GHz resonance frequency. Now at the most radius, which is radius of monopole at 4 mm. Now I am going to check for 4 mm. Here is the resonance frequency is 0.95 GHz. You can see that the resonance frequency slightly decreases with increase of radius of this antenna, which is good if we want to increase the bandwidth, but bandwidth is getting increased very significantly. Now I am going to mark at minus 10 dB. This is approximately at minus 10 dB. Here you can see that the bandwidth is 0.91 to 1 GHz. But in this graph, which is the most radius, here you can see that the bandwidth has increased significantly as compared to decrease of resonance frequency From here you can see that this is we have at 4 millimeter radius of monopole. The bandwidth is 0.5 has been increased. By increasing the radius, the bandwidth is 10% to 40% to 50% can be increased. We will discuss the theoretical explanation with the help of equation and with the help of graph. If you want to know this, you can check out the next part. The directivity is also increased with increase of radius, but it increases marginally. Now let's check the impedance plot on a Smith chart. Here you will observe by increasing the radius of monopole antenna, the inductance will decrease. Here you can see that this is the less radius value. Now by increasing the radius of monopole, the inductance is going to decrease. Here you can see that the inductance is increased from this much to this much, and impedance plot is shifting downward. This is the plot for a very thin radius. As you keep increasing the radius of monopole, this will shift downward. The inductance will decrease. Now let's check the radiation pattern. Here you can see that the radiation pattern is hardly changing by changing the radius of monopole. So that is why the directivity is hardly changing while changing the radius of monopole. And gain is changing because of the changing in VSWR of this monopole antenna by changing the radius of this monopole antenna. This was the result by keeping the fixed value of length of antenna and changing the radius. In next part we will see by keeping the fixed value of radius and length of monopole by varying the ground plane, what result will affect. And in next coming part we will change 2 parameters at the same time, and after that we will change 3 parameters at the same time with synchronized parametric sweep and unsynchronized parametric sweep, and we will see how the results are getting changed, so that finally you will be able, if you are going to design a monopole antenna for a specific application, for specific bandwidth, gain and resonance frequency, and you will be able to easily design a monopole antenna. We will also discuss the feeding method for coaxial feed we will give, and other feeding method we also discuss in coming part.